Very warm welcome to all of you students. Today's topic is relevance to the cluster analysis and data mining, the part 2. We have seen in part 1 what is clustering and different types of data. In today's lecture is relevance with MSc Computer Science, 4th semester, paper 4, data mining and data warehouse, unit number 4, prepared by me. I am SURESH Thakur, assistant professor, Department of Computer Science, Indira Gandhi Government Arts and Commerce College, Vaishali Nagar, Bhilai. Today we will discuss about the partitioning method and hierarchical method. This is the category of major clustering method. Today, these two methods, partitioning methods and hierarchical methods, will be discussed in this tutorial. Remaining methods will be discussed in next tutorial as part 3. So let's move to take knowledge about the partitioning methods and hierarchical method. Partitioning methods. Partitioning methods construct k partitions of the data such as k is less than or equal to n, where each partition represents the cluster. It classifies the data into k group which together satisfy the following requirement. Requirement is that each group must contain at least one object and each object must belong to exactly one group. A partition method creates an initial partitioning. It then uses as iterative relocation technique that attempt to improve the partition by moving objects from one group to another group. The general criterion of a good partitioning is that objects in the same cluster are close or related to each other, whereas objects of different clusters are far apart or very different. Hierarchical method. A hierarchical method creates a hierarchical decomposition of the given set of data object. A hierarchical method can be classified as being either agglomerative or divisive based on how the hierarchical decompose is formed. So we will take the concept in detail for classical partitioning methods. We are having two classical partitioning methods, that are the k-means method and another is a k-medoid method. The k-mean method is a centroid based technique. K-mean algorithm or method takes the input parameter k and partition a set of n objects into k cluster so that the resulting intra-cluster similarity is high but inter-cluster similarity is low. Cluster similarities is measured in regard to mean value of the object in cluster. Point to be noted: cluster similarities is measured in regard to the mean value of the object in a cluster, which can be viewed as a cluster centroid or center of gravity. The k-mean algorithm as follows. First, step 1, it randomly selects k of the object, each of which initially represent a cluster mean or center. Next step, for each of the remaining object an object is assigned to cluster to which it is the most similar based on the distance between the object and the cluster mean. It then computes the new mean for each cluster. This process iterates until the criterion function converges and the square error criterion is used by this following function, where in this function we will take a look where E is the sum of square error for all objects in the data set, where P is the point in a space representing given object. Mi is the mean of cluster Ci. This is the K-mean partitioning algorithm. We just take input as K, the number of clusters, and D, a data set containing an object or containing an object, and output. After apply this algorithm over the data set, we got a set of K cluster, and this is the method. Randomly choose K object from D, a data set, as the initial cluster. B, recap or repeat our C. Reassign each object to the cluster to which the object is the most similar based on the mean value of the object in the cluster. And next point, at next step, update the cluster mean. Calculate the mean value of the object for each cluster until no change. This is the example. This example related to K-mean method, partitioning method. Suppose we want to group the visitor to a website using just their age as follows. There we get the age of our visitor, 16, 17, 20, then 20, 21, 22, 23, 29, 36, 41, 42, 43, 44, and so on. Initial cluster, we are trying to design, we have decided two clusters. It means K equal to 2, and we got centroid C1 and centroid C2. And we just take two values randomly, and these two values assigned to different cluster. We have two clusters. So first we take the 16 for cluster 1 and 22 for the another cluster, and this is the mean value. But there is no, except of 16 and 20, there is no any value in cluster. So 16 is a mean for C1 and 22 is a mean value for C2 at first iterations. We again choose the value that is for a near to 16 and 22. According to this concept, we got the value in centroid as 16, 16, 17, and in context of centroid C2, we got the value as 20, 20, 21, 21, 22, 23, 29, as so on up to last value that is relevant to the 22, and we just calculate the mean value, then get at 16.33 for C1 and 37.43 for C2. At next iterations, we again some value choose from the centroid 2 to place the C1, and we look at the C1. We got the value at 16, 16, 17, 20, 20, 21, 21, 22 and 23, and the remaining values resides in cluster number 2, and we again calculate the mean for centroid C1 and mean for centroid C2. We get the iteration 2, the 19.55 as a mean value for centroid C1 and 47.2 mean value as a mean value for centroid C2. So let's go to the iteration 3. Again we pushing some values from centroid C2 to centroid C1. Then at iteration 3 we get the 16, 16, 17, 20, 20, 21, 21, 22, 23 and 29 in centroid C1 as mean value. After calculating mean value we get 20.50, and centroid C2 having value as 36, 41, 42, 43, 44, 45, 62, 63 and 67, and we are going to calculate the mean values for centroid 2. The answer is 49.22 is a mean value for centroid C2. Next we try to make iteration number 4, pushing some values. We don't need to pushing some values. When we compute again iteration 4, so there is no change on the mean values, no change between the iteration 3 and 4, so we stop. Therefore we get the cluster 16 to 29 and 36 to 66 as a 2 cluster we get using K-mean algorithms. So after that part we just move to K-meanoid method. The K-mean algorithm is sensitive to outliers because an object with an extremely large value may substantially distort the distribution of the data. This effect is particularly exacerbated due to the use of square error function. Instead of taking the mean value of the object in a cluster as a reference point, we can pick actual object to represent the cluster. Using one representative object per cluster, each remaining object is clustered with the representative object to which it is the most similar. The partitioning method is then performed based on the particular principle of minimizing the sum of dissimilarities between each object and its corresponding reference point. That is an absolute error criterion is used to define as these things like this one, where E is the sum of the absolute error for all objects in the data set, P is the point in space representing a given object in cluster Cj, and 0j is the representative object of Cj. The initial representative objects are chosen randomly. The iterative process of replacing representative object by non-representative object continues as long as the quality of the resulting cluster is improved. This quality is estimated using a cost function that measured the average dissimilarities between an object and representative object of its cluster to determine whether a non-representative object 0j random is a good replacement for a current representative object 0j. This is the k-medoid method. Input k, the number of cluster, d, a data set continuous and object, a set of containing n blocks. This is the output. And method, randomly choose k object in k as the initial representation object or seeds. Part B, repeat. C, assign each remaining object to the cluster with the nearest representative object. Randomly select a non-representative object, 0 random. Next step, compute the total cost as of swapping representative object j to 0 random. If s is less than 0, then swap 0j with 0 random to form the new set of k representative object until no change. This is, we are looking the example. We consider the coordinates which are shown in our table. We are having the 10 coordinates, the x and y. If a graph is drawn using this given data points, we obtain this graph. This is the x-axis, this is y-axis, and this is the coordinates. Relatively, we get the graph and points here. We are trying to take the to create a cluster for this example. Step 1, we choose the k equal 2, means the number of cluster we decide to be a 2 cluster. Let us randomly select 2 medoids C1, the 3, 4 coordinates, and C2, 7, 4 coordinates. Here is 3, 4 and 7, 4 coordinates. Step 2, calculating the cost. The dissimilarities of each non-medoid point with the medoid is calculated and tabulated. Likewise for this one, 7 minus 3, 6 minus 4 equal to 6, and 7 minus 7 and 6 minus 4 plus values equal to 2. We apply the formula for to find dissimilarities for C1 and dissimilarities for C2. Again, we just check how can we get 6 and 2. For C1, we are choosing the medoid randomly, C1. 7 minus 3 equals to 4. Plus 6 minus 4 equal to 2. Then we are getting the 4 plus 2 equal to 6. For C2, 7 minus 7 equals to 0 plus 4, 6 minus 4 equal to 2. Likewise, we are getting this all values regarding this x and y. Each point is assigned to the cluster of total of that medoid whose dissimilarity is less. The point 1 to 5 go to cluster C1, and this is the point 1, 2 and 5, and C1, 0, 3, 6, 7, 8 go to cluster C2. The total cost we get 3 plus 4 plus 4, 3 plus 4 plus 4 plus 3 plus 1 plus 1 plus 2 plus 2, that's it 20. Now randomly select one non-medoid point and recalculate the cost. Let us randomly select point 7, 3. The dissimilarity of each non-medoid point with the medoid C1, 3, 4 and C2, 7, 3 is calculated and tabulated again. We get this tabulation. Each point is assigned to that cluster whose dissimilarity is less. So the point is 1 to 5 go to cluster C1, and 0, 3, 6, 7, 8 go to cluster C2. The cost function we again calculate. We get the cost function 22 and swap cost, present cost 22 and previous cost 20. We get 2. As the swap cost is not less than 0, we according to this result we undo the swap. Hence 3, 4 and 7, 4 are the final method. The clustering would be in following way. We got this clustering, 2 clusters. In this cluster we get this value, and next cluster we get this values. So after taking knowledge about the partitioning method, we just move to hierarchical clustering method. A hierarchical clustering method works by grouping data object into a tree or cluster. The quality of pure hierarchical clustering method suffers from its inability to perform adjustment once a merge or a split decision has been executed. That is, if a particular merge or split decision later turns out to have been a poor choice, the method cannot backtrack and correct it. Hierarchical clustering method can be further classified as either agglomerative hierarchical clustering or divisive, depending on whether the hierarchical decomposition is formed in bottom-up, top-down fashion. This bottom-up, so let's take to discuss about the agglomerative hierarchical clustering. This bottom-up strategy starts by placing each object in its own cluster and then merge this atomic cluster into large cluster. Most hierarchical clustering methods belong to these categories. This is algorithm in front of our screen. Step 1, calculate the similarities of one cluster with all the other clusters. Calculate proximity matrix. Consider every data point as an individual cluster. Merge the clusters which are highly similar or close to each other. Recalculate the proximity matrix for each cluster. Repeat step 3 and 4 until only a single cluster remains. Divisive hierarchical clustering. This bottom-up strategy starts by placing this top-down strategy does the reverse of agglomerative hierarchical clustering by starting with all objects in one cluster. It subdivides the cluster into smaller and smaller pieces until each object forms a cluster on its own, or until it satisfies certain termination conditions, such as desired number of clusters is obtained or the diameter of each cluster is within a certain threshold. If we are going to compare the two different categories of hierarchical clustering method, that is agglomerative versus divisive clustering, we get the result as divisive clustering is more complex as compared to agglomerative clustering. Divisive clustering is more efficient than the agglomerative. Device algorithm is also more accurate. So thank you very much, all of you students, and again I would like to tell you that the data mining concept and techniques, GI Han and Michelin Campbell's second edition book is very suitable for our crack our exam in this semester, and I'm taking the example which have we discussed in our this tutorial, that example considered from this site. I'm very thankful to this Greek for Greeks.org site. It's very nice, nicely explained, thorough, lots of concept here. So we can choose, we can go through this site, and we can take lots of knowledge, and we can take lots of topic that is covered here. So thank you very much.